Thank you all for joining us for our walkthrough of the fourth grade bridge building activity. My name is Dylan Elizabeth from In4All, and today I'm joined by
New System from Bernier. All right. So the plan is that in this first activity that the students are going to build a bridge, and the object is to build the bridge that can hold the largest weight with the smallest amount of material. So let's kind of flip through the activity here a little bit, just so you can see, what you'll be presenting to the students, and I'll give you some tips and tricks and stuff. So Dylan, let's move along here. So let's take a look at the bridge building activity. First thing you want to do, download this activity from the In4All website and personalize these first couple of slides. You want to put in your own information, and you want to put in your own pictures and things like that. So I'd recommend that you do that. And then something to break the ice with the kids, right? Put this up here. What doesn't belong? I challenge you to see how many kids are going to pick out the darker triangle and how many kids are going to pick out the hexagon. It'll be interesting. Just kind of let them go. Don't tell them anything. Maybe do a little poll and say, which one do you think doesn't belong?
and why.
Yeah, I think it'll be kind of interesting to see, which kids pick this one, which kids pick that one. But anyway, just kind of a fun little thing. And then the issue is, what about bridges, right? These kids are in fourth grade. They've heard of bridges. They've crossed bridges. But, what is it about a bridge that's important to us? Okay, so why do we need a bridge instead of pole vaulting across a little creek or something like that? And so let's take a look at that just a little bit. Lots of different styles of bridges. And your students may get creative, and that would be really cool. The bridge I built here for the demo is not horribly creative, but I would love to see the bridges they built. So let's take a look and see what all is involved. Can they name the bridges on the Willamette? The only one on here that I can name right off the top of my head is the Tillotop. I'm having great challenges with the others, but it might be interesting to see if some of the kids recognize some of these big bridges downtown. So, all right, so here's your goal. You are going to get some paper and you're going to build a bridge. Okay. And then once you built the bridge, the idea is to see how much can your bridge hold. So this is the challenge. Okay. But let's take a look at what you have to work with. Okay. First thing you need to do is think about how you're going to do it. Now, the main rule here is you only get one piece of paper. Okay, so the first thing you might want to do is think about, how are you going to build your bridge? Okay, your first bridge, is it going to be the best bridge that you could ever build? I would challenge the students to, let's see, maybe it will be, but I would be surprised if their first try does come out to be the strongest one. Remember, one piece of paper. Build the bridge, test it, and then build another one. You're going to get every student's going to get 3 pieces of paper. So you're only allowed to build a bridge from one, but build another one. Are you going to build exactly the same bridge, or are you going to change it in some way? Make sure you jot down what you change in your bridge. Okay, so let's move on here and let's see what we got to go. You get one piece of paper. Now, if you look over here, I'm sliding my hand over in my little test area here. You need something to support your bridge. I have a couple of these boxes here that are the same height. And the big rule is that the gap has to be 6 inches. Okay, that's the big rule. So whenever you use boxes, books, whatever, tables, you can slide a couple tables close to each other, but the gap that you're trying to span is 6 inches. Okay, and then they will get 25 erasers. And trying to find something simple that we could use, and the idea here is to test and see how much it can hold. So design and draw your bridge on the activity sheet. So when you are building your bridges, the first thing to do is try to think about, what's going to make a strong bridge. Okay, and so there's a little timer here. Don't give them a little taste of that timer. There's a little timer here that you can use when you're making your presentation to the students, and give them a little bit of time to work together and come up with a design, okay, for their bridge. And so this is a brainstorming time. So different students could be coming up with different things, and Dylan's going through a very nice illustration of write down what your design is, right? Because you are likely going to need to change it. So we won't wait the whole 5 minutes here. build your first bridge. Now, once again, you get 10 minutes. I did mine in 2, just saying. Okay. But you got a 10-minute timer here so the students can build their bridge, and every student can build their own bridge. Right. So it's just one piece of paper.
So during that phase, you want to build and test your bridge, and you can do it as many times as you want individually.
Okay. So total bridge number 1, 10 minutes, build and test. Right. So once it's built, put your bridge down. Let me turn mine upside down and then test it. Here is 6 erasers. Ooh, here's 12 erasers. Oh, see if I can get them to sit on the bridge.
Don't forget about gravity.
Yeah, there's gravity is definitely a factor here. All right, there we go. My bridge is, I built it in 3 minutes, and Dylan will attest to that. So, all right, 18. 24. All right.
Everyone's full.
And I think, you notice mine's starting to tip over here. So there's also the issue of time, right? It's got to stay for a while.
Right.
Here's 25. Oh. That was 25, but I don't think that counts because it only stayed up for like a 30 seconds. So then challenge them. Hey, how about something a little different, right? So see if they can get, this might not be the best choice because of the coffee in there, but I built a bridge a couple of sessions years ago for In4All, and I had a stapler, and I was able to support the stapler. So challenge your students to maybe try something heavier than even the 25 erasers. Okay, and then you've got your erasers. Oh, does my bridge work better upside down? That's a little bit crazy. Interesting engineering action there.
Almost.
But anyway, in the 10 minutes, bridge number 1 has to be built and tested.
Ideally, you can do another iteration if it doesn't work the first time you test it. And so at the end of this session, hopefully you've got a successful bridge individually, because the next part is doing it together. So now that we've built our bridge a couple of times, we can talk about why. Why are we using paper to build this bridge?
That's a good point, is that there's always costs involved. And so that's a thought, is building a bridge or building anything that will be successful, but also may not cost as much as other materials and
Right.
time that's involved. So build another one, get 10 more minutes, but this time, take into account the things that went wrong with your first one. If you remember with my bridge, it was collapsing in the middle. Is there something I could do in my design that would support the middle better? Okay, and so you might think about those other types of bridges that were presented. I folded it a certain way. Maybe if I folded it in a different way, this piece of paper is longer than 6 inches. Could I do something where I build a different type of support on the ends? Okay, and so make sure that you take that into account when you're going to build your second bridge.
Now, the difference about this the second bridge is that we also encourage you to build together and work with a team. Usually teams of 3 or 4 work best. And so collaborate on a bridge design together, build your bridge together, and then test your bridge to see how it worked.
Very cool. Very cool. All right. Final test.
So once all groups have completed their final bridge, ideally the entire classroom can come together, go to the front or somewhere where all students can see, maybe a projector, so that each group can do a final test to see whose bridge can carry the most weight.
All right. I had a square design. Now I'm going to do a circular design. Let's see my gap there. Okay. Circular design bridge. No tape. So the bridge has to hold itself. Let's see.
Oh.
It's a fresh piece of paper and a circular design.
Ooh.
it's harder to balance on there, so I probably should have built a place with a payload. But it is interesting. I'm
At
up to
18?
18. Oh, and it doesn't look like it's collapsing.
At all.
Whoa, 24.
Ooh, getting a little wobbly.
Definitely not, but it's there. All right. Number 25. Dare I put it on there? Shazam!
Woo!
Yay! Deuce wins his own test. Okay, all right. Very much fun.
And once we've built our bridges, tested our bridges, we will have a second of reflection and talk about what worked, what didn't, maybe what surprised you in your first testing, in your second testing, in your final bridge. What would you do differently next time? And what are you most proud of the bridges you designed and built today?
Well, I was a little surprised the circular design worked better than the rectangular design. That surprised me.
Right.
What would you do differently the next time? Oh, I think I would try to add some folds somehow. This one, what was different was too, is I used the paper rolled in the opposite direction instead of the long way. I rolled it the narrow way. So anyway, what are you most proud of? Oh, just working with Dylan and In4All. That's so much fun.
Why, thank you. And next, you want to kind of tie in from your introduction session where you talked about what is STEM and kind of talk about how did we use STEM today in today's activity.
Yep, we use STEM in today's activity and in the introductory activity, you probably talked about your office or your job. You know, is there any STEM involved in that? And you might tie a little bit of that, you know, where STEM fits in everyone's life.
And I think here we're using a bit of the engineering design process to kind of brainstorm, design, build, iterate, retest. But I'm sure there's some math that goes into the shapes and the strength of what you're building. Also, the technology and the invention of paper is what got us to be able to use paper to make this bridge. And I want to argue that everything in life is science. So I would argue we're using the full STEM spectrum here. So yeah, pretty exciting and interesting to see what students might say to this prompt.
So just a little peek at the next activity for fourth graders called Marbles in Motion. And we will make a video for you of that activity as well.